Hello everyone, this is Shivraj Gurjar and today we'll discuss permutation group. ये जो पार्ट है ग्रुप्स का it was remaining in fact. ठीक है, तो ये important है in fact, इससे क्वेश्चन आ जाते हैं and it's doable है. ठीक है, so पहले we'll see जैसा कि नाम है permutation group. ठीक है, so what are these permutation group basically? Let us say there is this set A. ठीक है, let's say इसमें कुछ elements है A1, A2, A3 and so on. Let's say such n elements are there, right? So ये जो सेट A हुआ हमारे पास, मान लो इस सेट A से A में एक हम कोई मैपिंग डिफाइन करते हैं, मैपिंग F, where F is a mapping from A to A, where this set A is finite of course, because there are finite number of elements in this set, so this is a finite set. ठीक है, for our purpose we'll study this permutation group on finite set only. ठीक है, so we are assuming this set as finite set. so इस टाइप की मैपिंग्स होगी भाई यहाँ पे. जैसे फॉर एग्जांपल इफ आई टेक लेट से कि 1 to 3 एलिमेंट्स है सेट ए में, सो सेम सेट इधर भी रख रहे हैं अपन, सो यहाँ पे भी 1 to 3 एलिमेंट ही होंगे. सो इफ वी डिफाइन मैपिंग्स फ्रॉम ए टू ए, सो उस टाइप की मैपिंग्स. अच्छा, प्लस दे शुड नॉट बी सिंपल मैपिंग, इनफैक्ट दिस एफ शुड बी 1 1 एंड ऑनटो. ठीक है, basically bisective function होना चाहिए f. If this f is bisective, that is it is 1 1 as well as onto. 1 1 in the sense for every element of this domain there will be only one image for it. ठीक है, unique image will be there for every element, and for every element in this codomain A there will be a pre-image. So basically that's the definition of 1 1 and onto. So for every element वन, लेट्स से कर ये वन है, सो इसमें ऐसी पॉसिबिलिटी हो सकता है ना कि वन जो है उसका आउटपुट वन हुआ. बेसिकली F1 जो है वन आ रहा है, F2 2 आ रहा है, F3 3 आ रहा है ना, ऐसा हो सकता है. सो दिस इज वन सच मैपिंग. ऐसा भी हो सकता है कि F1 जो है वो लेट्स से 2 हो गया, F2 जो है 3 हो गया और F3 1 हो गया. This is also a 1 1 and onto mapping, because for every element in set A, 1 2 and 3, only these 3 elements are there. For every element there is a image, and for every image there is a pre-image. So this function f is 1 1 and onto. So ऐसे कितने फ्रेम कर सकते हैं अपन 1 1 and onto functions? ऐसे 6 कर सकते हैं अपन for these 3 elements. कैसे? उसका भी रीजन है, देखो 1 2 3 these are the elements, then 1 2 3 these are the elements in set A. So देखो for this one, this element, first element, these 1 2 3 are elements. Basically for simplicity we are denoting them by 1 2 3. This can be anything, A B C or anything. ठीक है, so अगर देखो if this one goes to 1, मतलब this one has 3 options, ये किसी तीन में से कोई भी इसकी इमेज हो सकती है. Basically F1 can be 1 or it can be 2 or it can be 3. ठीक है, so let's say कि F1 जो है वो 1 हो गया. So then this is fixed. One element from this domain is fixed with the one element in codomain, where domain and codomain both are same. ठीक है, so now this 2 has only 2 options. F2 can be 2 or 3. ठीक है, so F2 can be 2 or it can be 3. So let's say इसको अपन ने 2 पे फिक्स कर दिया. If we fix it at 2, so now 3 has only one option. So F3 has to go to 3 only. So F3 हो जाएगा 3. So total कितनी मैपिंग्स बना सकते हैं? For this we have three options, multiply by, for this we have 2 option, multiply by, there is only 1 option, so there are 6 such mappings. भाई इसमें F1 को 1 लेंगे, that time F2 can be taken 2 और F2 can be taken 3 as well, और F3 तो 3 होगा. ठीक है, so basically देखो एक तो ये हो गया सेट, ठीक है, और दूसरा ये हो गया F1 is 1, F2 is 3 and F3 3. So 2 ये हो गए, but when F1 is taken as 2, F1 is taken as 2, then F2 क्या होगा? F2 1 हो सकता है और 3 हो सकता है. और जो F3 है उसको तो फिर अब जो बैलेंस बचा इसमें, अगर F2 1 हो गया तो F3 को क्या होना पड़ेगा? 3 होना पड़ेगा. और अगर F2 3 हो गया तो F3 को 1 होना पड़ेगा. by one set will be F1, F2 and F3. This will be one set, right? And the other set will be F2, F, let's say, yeah, this is F1, this is F2, and this is F3. So यहाँ पे 2 हो गया. Similarly, we can say that there are 6 combinations. ठीक है, तो अगर if there are n elements, if there are n elements in this set, let's say यहाँ पे n elements है, यहाँ पे भी मतलब because we will have both set the same set, this पे key will define the mapping. So यहाँ पे if n elements are there, here will also be n elements. So if we define mappings from A to A, which are 1, 1 and 1, 2, so how many such mappings are possible? For this first element, there are n options. Okay. So once let's say कि F1 is 1, then for 2 only n minus 1 option are there, and so on. So this is nothing but n factorial. So there will be such n factorial mappings if a set A has n elements and permutation are done on these elements. ठीक है. So ये जो n factorial mappings बनी, इस टाइप की जो मैपिंग बनी F1, F2 एंड सो ऑन Fn फैक्टोरियल, ये जो मैपिंग बनी, लेट्स डिनोट दिस बाय, इसको कुछ नया सेट बोल दो, लेट्स से B. देन दिस सेट B इज अ ग्रुप, basically this is a group with respect to operation composition of functions, and these groups are known as permutation groups. So I hope it clear. So basic understanding is this only, that there will be a finite set. Let's say there are n element in this set A. Then what we do, that we do various permutation of these elements. The permutations are done in such a way that the permutation mapping basically should be 1, 1 and 1, 2. जैसा कि हमने यहाँ पे किया. So all those such mappings, the collection of all such mappings will form a group with respect to operation composition of functions, and these groups are known as permutation groups. Okay, I hope it's clear. So what are permutation groups? Basically, if we define these, so permutation groups are permutation groups. Okay, if a finite set, ठीक है, say A has n elements, then 1, 1 and onto mappings from A to A, from A to A, basically इसको we have to write this way. If a finite set A has n element, then collection of 1, 1 and onto mapping from A to A forms a group with respect to operation composition of functions. Okay, so this is the thing. So basically, and order of such group is n factorial if set A has n elements. ठीक है, these mappings are nothing but permutation on these elements, right? So that's why these are known as permutation groups. अच्छा, there is one more thing. We have studied that groups can be of two types, abelian and non-abelian. ठीक है, so these permutation groups will be in general non-abelian. Permutation groups are non-abelian groups. ठीक है, non-abelian groups for n greater than equals to 2. ठीक है, basically let's denote this permutation group on n elements by Sn. So then this this Sn, this is permutation group on n elements, ठीक है. We also say this is a symmetric group, symmetric group on n elements, ठीक है. And order of this will be n factorial. Order of Sn is equals to n factorial, where n is of course natural number, right? And यहाँ पे देखो इसमें n is 1, then this will be only identity element, ठीक है. And if n is 2, then this will be like n is 2 means what does that means? That means that जो set A है, it will have 1 and 2, only 2 elements will be there. So this is 1 and 2, this is 1 and 2, this is set A and A. So from A to A we need to see 1 1 and 1 to mappings. So there are only two possibility. या तो जो है मान लो ये F है mapping, so F1 will go to 1 and F2 will go to 2, ठीक है. और मान लो दूसरी मैपिंग है कि F1 will go to 2 and G1 and G2 will go to 1. So only these two mappings are possible. तो यहाँ पे जो S2 होगा वो क्या होगा, या तो this F or this G, only these two elements. We'll see shortly that this when element goes to itself, like F1 is 1, if for every element this is the case, like यहाँ पे F1 is giving 1, F2 is giving 2, then this is identity element of permutation group. So this F is nothing but identity element which we denote by E, and this 1 is going to 2 and 2 is going to 1. So this can be written as 1 2 in cyclic notation. This also I will discuss shortly. So 1 2. So these are the only two elements in S2. But because one element is identity and identity commutes with every other element, so these will be commutative. So S2 is commutative element. Basically this is abelian group. ठीक है. So greater than 2, not greater than equals to 2, basically greater than 2. यहाँ पे n should be greater than 2. So if n is greater than 2, then Sn is non-abelian permutation group और non-abelian symmetric group on n elements. ओके. अब देखो ये जो permutations है इनको साइकिल्स, इनका एक साइक्लिक नोटेशन भी है, साइकिल नोटेशन ऑफ परमुटेशंस, ठीक है. ये क्या है, ओके ये जैसे कि हमने ये डिस्कस किया कि अगर मान लो ये देर आर 3 एलिमेंट इन सेट ए, सो फ्रॉम सेट ए टू ए वी नीड टू सी 1 1 एंड ऑटो मैपिंग. सो ये हो गया. सो इसमें वन मैपिंग इज दिस, वन मैपिंग विच इज पॉसिबल इज 1 goes to 2, 2 goes to 3 and 3 goes to 1. Basically F1 is 2 and F2 is 3 and F3 is 2. Okay, so this means इसको we can write in basically this can be written in array form. This can be written as that 1 जो है, when we are applying F on 1, basically F1 will be nothing but 2. So image of 1 is 2 for F, basically F1 is 2. ऐसे F2 is nothing but 3. यहाँ पे if input is 3 then F3 is 2. So this is a array form, ठीक है. Let's denote this by alpha. So this is a permutation, yeah, this is a mapping, one mapping of course. So where F1 is 2, F2 is 3 and F3 is 2. So this is a array notation. और इसको cycle notation में if we need to write, तो cyclic notation क्या होगा इसका, cyclic notation of permutation वो होगा that 1 is going to 2, ठीक है, and 2 is going to 3, 1 is going to 2, 2 is going to 3, and then 3, this is 1, basically this is 1, right? Yeah, 3 goes to 1. Otherwise तो if यहाँ पे 2 हो गया then तो this won't be 1 1, because for every input there should be unique image, then only it will be 1 1, so it has to be 1, right? So ये हो गया. So अब देखो 3 के बाद again 1 ही आएगा, ठीक है. So now फिर 1 का output is 2, so then this is repeating. So basically 1, ये 1 भी we are putting extra, basically this is not needed. So this is the cycle basically. This will be read as this, that when input of f is 1, then that the image is 2, when input is 2 then image is 3, and when input is 3 then image is 1. So this is a cyclic notation of same thing. ठीक है, so I hope ये समझ में आता है. So this is also alpha only. This is array form, array notation, and this is cycle notation. ठीक है, और ये फंक्शन फॉर्म में अपन ने लिखा था कि f1 is 2, f2 is 3 and f3 is 1, right? So these are the things. So this cycle notation will use, because first thing this is short, and the other thing why we use is that also will come to know that there is a concept of disjoint cycles through which we'll be able to get order of element in this. ठीक है, अच्छा इसमें एक चीज है, जैसे ऑर्डर ऑफ एलिमेंट हो गया एक चीज, तो एक चीज हमने देखी कि ऑर्डर ऑफ द ग्रुप जो SN है यहाँ पे सिमेट्रिक ग्रुप, उसका ऑर्डर तो n फैक्टोरियल है. In case of there is only 3 elements, so S3 will have order 3 factorial, S4 will have 4 factorial order, and so on. ठीक है, and one more thing, these permutation groups have basically a lot of subgroups. They are subgroup rich. ठीक है, like S3 will have around 4, I think S4 will have around 40 or plus 100 subgroups. ठीक है, so there is no fixed way to get कि how many subgroup है. ठीक है, that is a manual exercise in fact, because these are non-abelian group, first thing. ठीक, अच्छा इसमें एक चीज़ है कि जैसे मान लो लेट्स से कि ये अपना सेट A है and it has element A1, A2 and so on, AM, B1, B2 and so on, Bn, and C1, C2 and so on, Ck. ठीक है, where M, N, K are integers. So basically देखा जाए तो A has M plus N plus K elements. ठीक है, A has this much elements. ओके, सो अगर देखो इसमें, अगर इसमें ये देखा जाए कि मान लो F, इस पे मैपिंग्स डिफाइन करें, मान लो F A1 Q A2, ठीक है, एंड F A2 लेट्स से गिव्स अस A3. ठीक है, और F A2 कैन आल्सो बी रिटन एज लाइक F A2 इज नथिंग बट F A1. So this can be written as F square A1, right? So this is A3. Similarly, अगर A4 की बात करें, so that will be nothing but F A3. Let's say that we have arranged the cycle in this way, A1, A2, AM. This is one cycle. ठीक है, on the elements of this. So this can be written like this. So A4 will be F A3. F A3 is nothing but, what is F A3? F A3 is ये A3 is F square A1. So this will be F cube A1, right? And so on. So अब देखा जाए तो if we see F AM, that will be, यहाँ 4 है, then there is 3 only. So this will be F power M minus 1 A1. ठीक है, this has to be there. Otherwise, if अच्छा, after certain amount, this should come out to be A1 only. If that is not the case, then what will happen, that this will go on and will have an infinite element in A, right? If let us say that this is not A1, then what will happen, that there will be FM A1 and so on. It will increase, like we started from A1, then F A1 and so on. So it will go till infinity. So it is necessary that this has to be equal to A1 after some time. So let's say that वो जो mth एलिमेंट है वही A1 हो जा रहा है, या m+1 अगर इसको करें तो यहाँ पे m होगा, right? Here we'll have m. So let's say that this has become A1. Okay, so this concept where f when f is applied m times on A1, then this gives A1 itself. Then this cycle alpha is of length m. ठीक है, this is a cycle of length m. So इसको we'll write like this, A1, A2 and so on am. ठीक है, that means this is a cycle of length m. This is alpha. So in this case what will happen, that अगर इसमें देखो alpha m, if we do A1, so this will give A1 itself. ठीक है, or इसको we can directly say that alpha power m is nothing but E identity. Okay, so this is the thing. So this is known as length of this cycle. Length of this cycle is m. देखो, there is a concept of order. Order of group is n factorial, but length of this permutation alpha is one mapping. ठीक है, so this is basically element of group. So for this it will be the length of this cycle will be m. ठीक है, but अच्छा इसमें let's assume that every other element is its own image. Like इसमें जैसे b1 है मान लो, उसकी जो एफ b1 है वो b1 ही आ रहा है मान लो, ऐसे ही जो c1 है वो c1 ही आ रहा है, देन दिस विल बी द केस. ठीक है, बट ये भी तो हो सकता है जैसे हम अपन ने ये एलिमेंट इस टाइप लिए, तो इसमें ऐसा भी हो सकता है दैट एफ b1 इज या b2 इज नथिंग बट एफ b1 एंड सो ऑन. जैसा अपन ने यहाँ पे किया वैसे ही देयर विल बी अ साइकिल ऑफ लेंथ n इन दिस केस. ठीक है, सो bn विल बी या bn plus 1 will be nothing but bn times या fn times b1, n times b1 which give us b1 itself. ठीक है, so this will be a cycle of length n. So that way alpha can be written as a1 a2 am b1 b2 bm and c1 c2 ck. Okay, where these a1 a2 am this is a cycle of length m, this is a this is n basically, this is cycle of length n and this is cycle of length k. ठीक है, so this alpha is element of group. ठीक है, and this is a combination of these three cycles. If we see here that then no two cycles have any element any indices common between these two. ठीक है, like here a1 a2 am are the elements, here b1 b2 and bm are the bn are the elements, so there is nothing common between them, and similarly these also. So this cycle are known as disjoint cycles. Disjoint cycles. ठीक है, I hope ये clear है. Disjoint cycles means there will be nothing common between them. Like कि अगर एक cycle 1 2 3 है, मान लो S4 के एलिमेंट है और दूसरा ये है सिर्फ 4 है, so then this cycle has length 3 and this cycle has length only 1. There is no element common between them. यहाँ 1 2 3 है and 4 ही है, so these are the disjoint cycles. Disjoint cycles. ठीक है, similarly 1 2 and 3 4 अगर S4 में लें तो these are also the disjoint cycle because there is nothing common between them. Length of this cycle is 2 and this also 2. If this is the permutation alpha, then these two are the disjoint cycles. ठीक है, so I have it clear है, disjoint cycle वाला concept समझ में आया होगा. So basically any permutation any element of a permutation group can be represented as multiplication of disjoint cycles. ठीक है, this is also a theorem in fact. ठीक है, any element of permutation group let's say Sn can be represented as multiplication of disjoint cycles. ओके, आई होप क्लियर है. ये प्रूव भी की जा सकती है चीज़. ठीक है, ऐसे एक चीज़ हो रहा है दैट disjoint cycles commute with each other. Okay, so these both things can be proved.